Hello, welcome to another GeoAI tutorial. In this video, I'm going to show you how to use the population dynamic foundation model to do prediction on the US median home values at the county level, and also how to visualize the prediction and also the PDFM features in 2D and also 3D. First, let me show you what it looks like. So this would be, for example, the US median home values using the geo data, and you can actually visualize them easily using leaf map just with couple lines code. And I'm going to show you step by step, so you can see you can turn this kind of extrude the home values in 3D, and you can also show the labels on top of the counties. If you click on any of the county, it will show you, for example, the name of the county, the state, and also the home values, median home values of this county in October 2024. So this is pretty recent data. You can check out the link. I will put the link in the video description below. Lower right corner here, you can also see, for example, the category. So you can choose any classification schemes to visualize the data. So if you want to follow through, you can go to the GitHub repository to download the notebook. So in here, this is the report that I created yesterday, just to show you some of the tutorial about GeoAI. And the first one we're going to dive into is the PDFM. So the Google's population dynamics foundation model they released two weeks ago. And so in the previous video, we have covered how to map prediction of geo home values at the zip code level. And so for this video, we're going to talk about at the county level. Again, you are also welcome to check out the website here. And the second one, map PDFM features. So you can run this one in Google Colab. So just open this one in a new tab, and you can just comment this one to install the required packages, and then you can follow through step by step. But you do need to request access to the PDFM embeddings. So just follow the instruction, click here. It will take you to the PDFM GitHub repository. So then you can request access. And once you receive the approval from Google, then you can download the embeddings, then you can follow through. And I'm going to run this one using my local Jupyter Lab. So as you can see here, on the left side, you can toggle the table contents. So I'm going to go through step by step. The first, you need to import all the libraries. So I'm going to use Panda, GeoPandas, Scikit-learn, and also LeafMap. And LeafMap can help you visualize the data easily in both 2D and 3D. First, let's try to download the data. So again, the geo data we're going to use, you can click the link here. It will take you to the website, probably because press and hold. So the data we use today is the county level data. So once you have access to the data, so this is the one that I was using, so the time series, and then using the county level, then click this button to download. I actually already downloaded and put it on GitHub, so you can just use this URL. After that, it's going to download to my local directory under the data folder. And so if you don't have it, it's going to download, yeah, because I already have that. It's under my data directory, and it's this geo home values indexed by county.csv. So if you open it, you'll be able to see the data here. So we have county, and then if you scroll to the right, this is a lot of data because the data started from 2000, and we have monthly data, basically the home values for the entire US by county. And so latest one is October 2024. If you, let me see how many counties, it should be over 3,000. So right now, let me see here, it's 3,073 counties in total. So there's a lot of data set. And once you download the data, we need to basically clean up a little bit and to create basically the index. So what we want is this GeoID, because the PDFM embeddings, they also use this GeoID. So we just need to make sure that they have the common column so we can join the two tables together to do analysis. So once we have this ready, then we need the county boundary, because the geo home data is just a CSV, so it doesn't have geometries. And the PDFM embeddings, they also provide the county geostation data, but technically you don't really require this one. You can also get data from the county GeoJSON, just otherwise Google, you should be able to find the freely available US county GeoJSON data. But because this one already have this column, so this index column, so it's much easier for us to join the data. So again, you're going to check whether you have this county GeoJSON under the data directory or not. If not, then you can request the embedding. And once you have that, we can read the data and then set the index as the place column. So right now you see here, this one is the geodata frame. So we have this index column. It's the same as the one we use for the geo data. So once you have this, we can just join the two data frames together. So we're going to join the county geometry to the geo data frame. So in that way, we have both the home values and we also have the geometry. So if you scroll to the right now, we have all the home values, and also we have this geometry column. So with this, now we can use a leaf map to do the mapping. Since this is a relatively large data set, and because you can only visualize just one column at one time, so we don't necessarily need all these time series data. So what we can do here is just to just select one column. So for example, we want to select data home value for October 2024. And then, so we also want the region name. The region name basically is just the county name here. So again, let me scroll to the left, because we want to use some of the information when user click on the map on the polygon. You will show, for example, the region name, it will be the county name and also the state. So then will be the home value and also the geometry. With that, now we have the geodata frame that what we need, including the index, county name, state name, home value, and also the geometry. So once we have this data frame, now we can visualize using leaf map, and we are going to use the map libre mapping backend because we have 3D. So then you can run this one to see what it looks like. It should be just within a couple seconds. Then it's going to load this one as map. So here we can just call this add data function. So this is the new function that I just added earlier today. And you can add a CSV, a GeoJSON, or data frame, or something like that. You can also specify, for example, a color map. So the color map here can be anything supported by Matplotlib. And the column is this column. So we specify this column, basically October 2024. Then you can specify legend, low right corner here, it will be just this legend title. And the layer name, so it will be this one. Then also the last one is the before ID. Before ID means whether you want to place the layer beneath symbol or not. Symbol basically means this label. So if you don't provide this one, let me just show you here. Then you'll be just, the layer will be on top, so you don't actually see the label. Technically, it's up to you, but you can click here. You can also see, for example, the county name, the state, the home value, and these two actually is just added under the hood when you're trying to classify using this color map. So it supports different classification methods. So for example, Shift tab, you should be able to see the help documentation. So for the schemes here, by default, we are using the quantile. So it will be 5. So 5 categories. So it's relatively even, but you're welcome to specify different, right? So these are different types of classification. But actually just creating place maps using the data set. So it would be nice that we use this first symbol ID. So the map, you can use the 5 first symbol layer, and the layer has the ID attribute. And this is where you're going to find, basically it's going to find out this one, and then going to place the layer beneath the symbol. So in this way, it looks better, right? So we have the data layer, and we also have the label on top. And now you can click. Like I said, you can change this one to any color you like. So for example, the Matplotlib color ramp. So for example, I can say cool warm. X1 as well. You can change to any color you like. For example, right now, blue color represents lower home values, medium home values, and red color represent higher. So you can see basically the classification scheme in this case. So it's pretty even. So you can see near the coastal area, these are all like high values. And at the center here, for example, in the south east, you will see those actually, and also the west side, they are relatively low, medium home values. And so let me change this one back to blues so that it's consistent. So this is visualized using 2D, but because we have this column here, the home value, we can actually visualize it in 3D. So what you need to do is actually pretty much similar to what we have in here. The only thing that you need to specify is this one, extrude. Extrude means do you want to visualize in 3D and you're going to extrude the values, and also you can specify a scale factor. So that means whether you want to divide the home value by this number, because the home value might be too big, and so if the height is just too much, it might be hard to see. So let me visualize this one. So it looks pretty good. If you don't specify the scale factor, you might probably just extrude too much. So right now this is a little bit too much because there are some extreme values in here. So if you're seeing these values like right now is too much, you can just divide this scale factor. So the larger the number, the lower the height is going to be. So that's why you can test it. So I use like 3, and this looks pretty good. So this would be much easier, right, compared to the color. So the color already represent basically the darker color, the higher the home value, but it's even better because we can extrude the height. So you can very clearly see that here, in the coastal area, west and east coast, you can see these are pretty high. And interestingly, there are also two, like in the west here, Teton County, and what's this one? Pickens County in Colorado. So those are also very high values. The median home value is over 2.4 million. That's huge. And this one is probably just New York City, somewhere here. Oh, Massachusetts. No, not Massachusetts. Let me see here. Yeah, Massachusetts. This one is also $2.7 million, and similarly here in Miami, it's over $1 million. So it's pretty high values. And I can also look at somewhere here, for example, Knoxville, where I'm located, and you can see the county, Morgan County. I think it's the Knox County. Where is it? Let me turn this one off, or somewhere here. So the surrounding. Why I cannot find Knox County? Oh, it's here. Let me turn this one on. Oh, this one here. 357. So it's kind of in the middle. So it's not too high, not too low. So this is how you can visualize the data home values easily using leaf map. And essentially just create a map, and then you can add any geodata frame using the add data function, and then specify what color do you want, which column you want to use to color it. So in this case, we're going to use this column, right? This is the home value, and then specify the title for the legend, for the layer name, and then whether you want to extrude or not, whether you want to place the layer beneath the symbol, basically the label, and then lastly add the layer control. That's it. So this is how you can visualize the home data. So next, let's see how we can visualize the PDFM county embeddings. And like I said, you need to request access to the PDFM. Then I can read the data. So here I'm going to show you the PDFM, the county embedding is similar to the zip code embedding that we covered in the previous video. It also has 329 or 330 features. So this is basically what the PDFM is about, because it has been trained on a lot of data, and this is kind of the feature that has been extracted. And also you can see the county name, so also the index column, right? So once we have this, we can actually join that one to the county boundaries, because the embedding itself is just a CSV. You don't really see the geometry. So in order to visualize them on the map, we need to join the embedding to the county geodata frame. So again, this is also from the zip file inside the embedding, right? So what we are trying to do here is to have this embedding joined to the GeoJSON. Then we can visualize them. So all we need is just use this stock join, and it's going to join based on the index. So this will be the common index, GeoID column. And after that, you can take a look. So now we have this, the county, the geometry at the last column, and also the index. Again, they are very much similar. So you can scroll down. I think this is also almost 3,087 counties. So it's not exactly the same as the home value because some of the county might have some missing data. So this is 373. This one is 387 columns, rows. So how many counties? So once you have this, now we can pick up whatever feature we want to visualize. Like I said, it has 330, so you can pick up any of the features that you want. For example, I can pick the last one. So all you need to specify this column name. And like I said, this is the last data set. So for the visualization, we only need one column. So you're going to select the last column here. And also we're going to add, for example, the state, county, and also the geometry. So in that way, when you click on the map, you can see that. Okay, so run this too. Now take a look. So this will be the county embeddings from the PDFM. You can clearly see some patterns in here, although we don't really know what exactly does this represent because each feature stands for something at the county level. So for this one, you can see the value range here from 0.17 all the way to 18.3. Probably you can do some machine learning to figure out, for example, each feature is what it's about, or you can use maybe the principal component analysis to reduce the number of columns, but that you might lose some generalization of the data, so it might not be very accurate when you're trying to use that for prediction. But anyway, so this is what it looks like for the feature 329, and you can turn this layer on off. You can see some like high values around surrounding some of these, and most of these might be near the big cities, but it's not exactly the same. So I don't know what does it really mean. Also, the other thing you need to you can here, let me try the other ones, right? So you can also change, for example, feature 100. You just need to change it once. The pattern might look different, right? So now this looks very different from the other one. So basically every feature stands for something that's extracted from the spatial temporal relationship between those counties based on a large amount of data. So again, if you want to learn more about the PDFM, go to the GitHub repository, and this one shows you more details, and also there's a paper. So essentially, all those features is aggregated from Google search results, maps data, business, and also some environmental variables like this. And it's very complicated. So what we're trying to do here is just to visualize some of those to see if we can identify what it is. But clearly, this will be very hard to interpret because we don't really know what exactly do this mean. And maybe try another one, for example, feature maybe 200. Okay, it looks even more, right? So this one is kind of high value in the center. And so you can also visualize them in 3D. So similarly, this is, let me change it back to 329. Because otherwise you need to adjust the settings because here, this is the one, use the scale factors in here. So if you, basically it's the value divided by this scale factor. So because we will try to extrude it, and maybe you can extrude a little bit more, I can change it to 0.017, so it should be extrude a little bit higher. And this is essentially what the PDFM feature is about. So you can see here, this is relatively flat on the west side, and it's higher on the east side. And again, I don't really know what does this represent. It's just one of the 330 features, and you're welcome to explore, see if you can find some common patterns to figure out what does this represent. So if I change this one back to 329, and if you visualize again here, this is in 2D. You can see some patterns in here, some cluster, and this is in 3D. Okay, so this one, you see very high some of this in here, and that's why earlier I used 0.05. So in the way the value is not too high, you can see some patterns like this. Okay, and so this is just the embedding. So next, I'm gonna show you how you can actually do build a model to do the prediction on the home values using the PDFM. So first, let's join the home value data to the embedding, because again, the embedding just CSV, it doesn't have the housing data. So we basically join the two tables together, and in that way we have the embeddings, but we also have the home value. So here, right, this one, the date This one represents the home value. This represents just the features. So because we want to do the build a model, we need the home values. We also need the 330 features. And you can, because the home value has its time series data, so you can change to whatever day available in the home value. We're going to use the latest one, October 2024, as the label. And then we can delete all the no data. So you don't necessarily have to, but when we try to build a model, we can delete the no data, but you can actually use the PDFM to predict the median home value for these missing counties with missing data. Maybe I can do that in another video. But for this one, this is for to make it simple. We just delete all the, remove all the no data. So after that, we're going to have basically extract the data with 300 columns, 300 features, and also the label. So this will be the housing, the home values. This will be the PDFM features, and then change them to X and Y. So basically just two data frame. Then we just passing into the scikit-learn train test split. So what we're going to do here is 80% used for the training, 20% for testing. And so let's just run this one. Once we have the training and test data, we can just build a model. So we're going to use the linear regression model, and we're going to fit the model. And this will be the training data. This will be the X, basically the samples, and this will be the true values. And then you're going to predict based on once you build the model, fit the model, we're going to predict the home value for the 20% of the test data. So, and this is basically just the home value. So it'll be just a list of values, and we're going to join them, basically make it easier to compare. We're going to create a data frame. So this will be the actual home value. This will be the predict home value, and we can calculate the matrix. So for example, now we have the R square, 8.81, so it's pretty good, okay? And also you can see the relationship. It's basically 0.9 value is very high. And lastly, we can actually plot the scatter plot, compare the actual values. So basically, I'm going to plot these two columns and then take a look of these home values. So this will be the actual home values. This will be the predicted. So it's 20%, so roughly 600 counties. And you can see it's pretty close. You can zoom in, you can see the details. So the closer to the diagonal line, the better. You can see most of them are concentrated. Of course, this one here is that the actual home value is only, for example, 600K, but the predicted is close to almost 1 million. So this is overestimated. This should be underestimated. But overall, you can see most of the points actually center around this area. And also set the limit to 1 million. If you set it to a larger one, you will see a little more some points, right? So for this one here, this is, oops, or you can just select. So I'm going to unselect this one. So for example, for this one, the actual home value is 2.4 million, but the predicted is only 1.3. So this one is highly underestimated. Again, I'm going to change it back. So, and this is how you can simply build the model, just a simple linear regression model to predict home values using the PDFM foundation model without having to actually create extract those features yourself, because it's already ready to use. So once we have the predicted home values, now we can actually visualize them. So in order to do that, we need to join this one as a data frame. So if you can see, what we have right now is this evaluate DF. So you can show it here. And this is what it looks like, right? So we have this column here, the index column. We have the Y is the actual home value. Y predicted is the predicted home values, but we don't have the geometry. So in order to visualize them on the map, then we need to join this prediction evaluation data frame to the GDF, basically the county. And also we're going to create a new column called difference. So in that way, we know like how far away from the prediction, away from the actual home values. So this is the prediction minus the actual home values, and then construct the geodata frame, and we drop some unnecessary columns. Then after that, we should have this geometry geodata frame that we can visualize. So we have these three columns that we need for the difference. So we're going to visualize them one by one. For the first one, we're going to visualize this column, the Y column. So this one is the actual home values for testing, right? Because we have, right now it doesn't have full coverage, because 80% of them were used for training. We only do the testing on 20%. So the counties that are shown here is the 20% of the US counties. So you can clearly see this is the actual home values from the zero data for October 2024. And we can also map the predicted one. So this will be the predicted home values based on the PDFM model. So you can clearly see there are some differences, right? We have some of these like very extreme values. The model is struggling because extreme value is always hard to predict. It's getting closer, but it's still going to be some kind of difference. So this will be the predicted home values. And the last one is the difference. So we can actually show the differences between the home values. And if you look at this one here, the blue color represent underestimation. The red color represent overestimation. So that means in this area, the value, for example, here, the Y and the predicted. So this is much higher than the original one. And but there are also some county, for example, blue one. This one is underestimated. So underestimated 122K or something like that. Because it has negative values, so that's why it's kind of the 3D doesn't look super nice because it doesn't go beneath the surface. You can add some kind of a make the difference maybe absolute value so you can see the variation, but this is how you can actually clearly visualize the how home values using leaf map and just couple lines code. So super easy to do, and you're welcome to try this out yourself, but you do need to request the embedding if you want to run the source code. But at least you can visualize the map here using the link that I provided. All the link will be provided in the video description below. So this is the original Geo home values for October 2024. And okay, so that's all I want to show you in this video. I hope you find it useful. I will see you in the next one. Take care. Bye bye.